first nebular hypothesis, or it was also known as gaseous hypothesis or condensation hypothesis. What this proposed was there was a very big cloud of hydrogen, helium, and dust particles, and it was rotating in an anti-clockwise direction very slowly. When gravity started acting on it, it started to pull matter inwards, which led to the core to get denser. And as matter was colliding with each other or due to friction, the temperature started rising. As the cloud got smaller, in order to conserve the angular momentum, the speed of rotation increased. The conservation of angular momentum here was explained by Laplace. In order to explain the increase in rotation speed, conservation of angular momentum had a role to play. This was explained by Laplace. If we want to understand the conservation of angular momentum with an example, we can say that how an ice skater, when they start rotating and they're comparatively, when they are bigger, as such their hands are spread, they rotate at a certain speed. But when they scrunch down, get their hands closer to the body and scrunch down, in a way get smaller, they start rotating comparatively faster. In the similar manner, this cloud started rotating faster, and as it started rotating faster, centripetal force started acting on the particles and started pushing the particles away from the center, while gravitational force started trying to pull them inwards towards the center. Hydrogen and helium were at the center, concentrated at the center, as they can withstand higher temperature, which eventually formed our protosun. And as centripetal force and gravitational force were working against each other, this cloud formed into a disk shape, converted into the disk shape. As the particles were undergoing accretion, it is that they were colliding, undergoing cohesion, and were staying stuck with each other. They started forming planets, and our protosun eventually formed the sun. This is the nebular hypothesis as was